and uncover the incredible science behind the stuff that makes up, well, pretty much everything. So let's dive right in.
No, seriously, go ahead, take a look. The device you're watching this on, the chair you're sitting in, it all feels so solid, so complete, right? But what if I told you that all of this amazing complexity is built from just a handful of fundamental ingredients?
Okay, let's start with the gadget that's probably in your hand or on your desk right now. Deep inside, it has a tiny brain, a chip, and that chip is made from one of the most common elements on Earth, silicon.
And that chip, it's wrapped in a case held together by metals that give it strength and, of course, let the electricity flow. See, right away, we're seeing how different materials team up to create something totally new. And honestly, that's the key to everything we're talking about today.
And, understanding and even inventing new materials isn't just for scientists in some far-off lab. It is the engine that is literally building our future, from computers that are way faster to getting us to Mars.
So to get started, it really helps to think of the classic engineering materials as belonging to four main families.
First up, the family we all know and love, metals. I mean, think about it. The Bronze Age, the Iron Age. These guys have been the workhorses of human civilization for thousands of years.
There's a reason metals are the backbone of our industrial world. They're strong, you can bend them and shape them without them breaking. That's what we call ductility. And they are fantastic at conducting heat and electricity. From the steel and skyscrapers to the aluminum and airplanes, metals are just everywhere.
All right, next up, let's meet a family with a totally different personality, ceramics. If metals are the strong, flexible members of the family, well, ceramics are the tough, unyielding ones.
And this is where it gets really interesting. Ceramics are incredibly hard and can take insane amounts of heat. That's why they're used in things like jet engines and super sharp cutting tools. But their real superpower? They're amazing insulators. They stop heat and electricity dead in their tracks, which is the exact opposite of what metals do.
Our third family is the one that really, truly defined the modern age we live in, polymers.
I want you to picture polymers as these incredibly long, tangled-up chains of molecules, kind of like microscopic spaghetti. This unique structure is what makes them so lightweight, so flexible, and so easy to mold. We know them best as plastics, and they have completely shaped our world, from the packaging on our food to actual life-saving medical devices.
And that brings us to our fourth and final family, which is kind of like a material super team, composites.
So, composites are basically the ultimate custom job. You take two or more different materials, you combine them, and you get the best properties of each, creating something brand new. Just think about carbon fiber. You've got these super strong carbon threads embedded in a flexible polymer. And what do you get? A material that is both unbelievably strong and shockingly light, perfect for building a Formula 1 car or a massive wind turbine blade.
So, there you have it, our four families. They've built our cities, they've powered our industries. But the big question is, are they enough for what comes next?
I mean, the challenges we're facing today, from finding clean energy to exploring space, are demanding way more from our materials than ever before. Look, the bottom line is this. The challenges of the 21st century demand more. We need materials that are stronger but lighter, tougher, and just plain better at handling extreme conditions. The old playbook just isn't going to cut it. We have to start inventing materials with properties that we once thought were basically impossible.
And this is where science starts to feel a lot like science fiction. Let's take a look at some of these next-generation materials that have what you could only really describe as superpowers.
So first up, meet graphene. Now, it's related to the graphite in your pencil, but it's something else. Imagine taking that graphite and slicing it down until you have a layer that is just one single atom thick. That's graphene. It's a two-dimensional material that has some seriously three-dimensional superpowers.
And this is the perfect example of how material structure creates its abilities. That single sheet of atoms is stronger than steel, it's more conductive than copper, and it's almost completely transparent. The possibilities for things like flexible electronics, aerospace, and medicine, they're absolutely mind-boggling. Okay, next up, a material that seems like it actually has a memory. Shape memory alloys are metals that you can bend, twist, completely crumple up, but if you just apply a little heat, they will snap right back to their original form almost like magic.
Now, this is not just some cool party trick. This technology is literally saving lives. A tiny medical stent made from a shape memory alloy can be squished down, guided into a blocked artery, and then, just from your own body heat, it expands back to its remembered shape, opening that artery right up. It's real-world magic, plain and simple.
And how about materials that are actually designed to work with our own bodies? Well, that's where bioceramics come in. A material like hydroxyapatite is so chemically similar to our own bone tissue that the body doesn't just tolerate it, it actually welcomes it. Bones can literally grow onto and fuse with it. This has thrown the door wide open for better artificial joints. And get this, creating scaffolds that can help the body regrow its own bone.
So where is all this heading? We've gone from the basic materials that built our world all the way to advanced materials with these incredible specific superpowers. So what does this all mean for the future that we're building right now?
You know, we built the modern world with materials that were strong, that were reliable. But the next world, it's going to be built with materials that are smart. Materials that can react, adapt, heal themselves, and even become part of our own biology. So the question isn't just what we can build anymore. It's what kind of world will these new, intelligent building blocks even create? What do you think?